Hey everyone! Ever wondered how your phone connects to the internet so seamlessly? Or why telecom networks can handle billions of devices without crashing? The answer lies in the brains behind the scenes, AI models that manage these complex systems. But here's the thing, not all AI is created equal. Today, we're diving into a groundbreaking paper that's shaking up the telecom world by introducing a new kind of AI, large concept models, or LCMs. Let's break it down. First, let's talk about the old guard, large language models, or LLMs. You've probably heard of them. Models like GPT or BERT that can write essays, code, or even joke around. They're amazing, but they have blind spots. Think of LLMs as detectives who only look at individual clues one at a time. They break down text into tiny pieces called tokens, like splitting a sentence into words or parts of words. While this works for simple tasks, telecom networks are anything but simple. Telecom systems are like giant, layered puzzles. There's the physical network, think fiber cables and towers, the software managing them, and the ever-changing rules governing everything. Plus, data comes in all shapes, text from technical documents, voice calls, sensor data, and more. LLMs struggle here because they can't keep track of the big picture. They lose context when dealing with long texts, miss connections between different layers of the network, and can't easily mix different data types. It's like trying to solve a 1,000-piece puzzle by only looking at one piece at a time. Enter large concept models, or LCMs. These models are the next evolution. Instead of focusing on individual tokens, LCMs think in concepts, the bigger ideas behind the data. Imagine if that puzzle detective could see the whole image at once, recognizing patterns and relationships between pieces. LCMs use a special kind of math called hyperbolic geometry to organize information hierarchically, like a tree where each branch represents a concept. This lets them handle complex telecom tasks like predicting network outages, optimizing 5G connections, or even translating technical jargon across languages. Here's where it gets cool. Let's say you want to set up a 5G network slice for a smart city. LLMs would juggle thousands of tiny tokens, settings, codes, and rules, while LCMs condense all that into a single concept that captures the whole plan. It's like replacing a cluttered spreadsheet with a simple flowchart. LCMs also excel at mixing data types. They can analyze a voice call, a sensor alert, and a technical document all at once, spotting issues a traditional AI might miss. What makes LCMs different? Let's get technical. Traditional LLMs rely on token-based processing, where each word or subword is treated as an independent unit. This creates a linear, flat representation of data. But telecom systems require contextual reasoning, understanding how a 5G protocol interacts with network slicing, or how a software update affects edge computing nodes. LCMs solve this by embedding concepts into a hyperbolic space, a mathematical structure that mirrors the hierarchical nature of real-world systems. In this space, related concepts like network latency and co-S metrics are closer together, while unrelated ones are farther apart. This allows LCMs to infer relationships and make decisions that align with telecom-specific constraints. The implications are massive. For example, LCMs can dynamically adjust network resources based on real-time data. If a sensor detects a surge in traffic from autonomous vehicles, an LCM can instantly reallocate bandwidth without human intervention. They also excel at symbolic reasoning, interpreting rules like 3GPP standards or SLA agreements. Unlike LLMs, which might suggest a configuration that violates these rules, LCMs ensure every action is compliant. This reduces errors and speeds up deployment. So why does this matter? Telecom networks are the backbone of our digital world, and as they grow more complex, old tools are falling short. LCMs aren't just a tweak, they're a leap forward. By thinking in concepts instead of tokens, they're paving the way for smarter, faster, and more reliable networks. Whether it's keeping your video calls stable or enabling the next generation of IoT, LCMs are rewriting the rules of what's possible. Stay tuned for more deep dives into the future of AI and telecom.